Title: Advanced Materials for Enhanced Mechanical Performance, Investigating Composite Materials in Structural Engineering. Welcome back, science enthusiasts. Today, we'll explore advanced materials for improved mechanical performance in structural engineering. Our research proposal aims to revolutionize the field through the development of composite materials. Composite materials have transformed the world of structural engineering, offering superior mechanical properties and the potential for lightweight, high-strength applications. Our research focuses on investigating and developing advanced composite materials to enhance the mechanical performance of structural components across industries. Our objectives are clear. We'll begin by investigating the mechanical properties of different composite materials, including fiber-reinforced composites, laminates, and hybrid composites. We'll conduct extensive mechanical testing, including tensile, compressive, and flexural tests, to analyze the behavior of various fiber and matrix combinations. By studying materials like carbon, glass, and aramid fibers, and epoxy or thermoplastic matrices, we'll gain valuable insights. But that's not all. We'll also analyze the structural behavior and performance of composite materials under different loading conditions and environmental factors. Using advanced finite element analysis (FEA) and numerical simulations, we'll explore stress distribution, deformation patterns, and failure modes. These insights will help us understand how composite components perform in real-world scenarios. To achieve optimal mechanical performance, we'll focus on optimizing the manufacturing process of composite materials. We'll investigate the influence of curing temperature, pressure, and post-processing techniques on mechanical properties and structural performance. By refining the manufacturing process, we can unlock the full potential of these advanced materials. Now, let's explore the practical applications. We'll conduct in-depth case studies to examine the potential of advanced composites in aerospace, automotive, and civil engineering. We'll evaluate the benefits, limitations, and challenges of implementing composite materials in these sectors. From lighter, stronger aircraft components to more efficient and sustainable automotive structures, the possibilities are exciting. Of course, we can't ignore the economic and environmental aspects. We'll conduct a comprehensive analysis to assess the feasibility and sustainability of composite-based solutions. By considering material costs, manufacturing efficiency, and life cycle analysis, we'll determine the economic viability and environmental impact of composite materials in structural applications. In conclusion, our research will provide a comprehensive understanding of composite materials' mechanical properties and structural behavior. We'll optimize manufacturing techniques, explore potential applications, and conduct economic and environmental analysis. Together, we can pave the way for lightweight, high-strength structural components in aerospace, automotive, and civil engineering, achieving greater efficiency, performance, and sustainability. Thank you for joining us on this journey into the world of advanced materials in structural engineering. If you found this informative, give it a thumbs up and subscribe to our channel for more captivating content. Until next time, let's keep pushing the boundaries of science and engineering.